Okay, we're going to continue our 1033 Test 3 review by looking at a couple questions from number 5, Part A and B, and then I'm going to do Part C and D on a different video. I want to explain these. These equations that we're looking at now are called literal equations. They have more than one letter in them. When you're solving a literal equation, sometimes also called formulas, it's important to know what letter you're solving for. But you basically still use all the rules of algebra, like you did when you were equation solving. And let's look at some. Let's see how you need to approach these problems. All right, here's our first example. J equals mn divided by u, and we're solving for the letter m. Now, one of the things that you want to do when you see an equation that has a fraction in it is you want to try to go ahead and get rid of the fraction. Now again, what's kind of neat on this problem, if you write this j as j over 1, one fraction equals another fraction, so what you've basically done is you've set up a proportion, and when you're solving a proportion, one of the quickest ways of doing that is to cross multiply. J times u is ju equals 1 times mn is of course mn. So we've gotten rid of the fractions, in this case by cross multiplying. Since we had a proportion, it was pretty easy to do. Now we're trying to solve for the letter m. Well, we're almost done, to be honest, because the right-hand side of this equation has all of the terms that contain the letter m. The left-hand side of this equation has the terms that don't contain the letter m. So they're already separated into their sort of family reunion locations. Now, on the right-hand side of the equation, to get the letter m alone, which is what solve for m means, I'm going to undo multiplication, and I'm going to divide both sides by n. And of course, on this side, we have one term on the top, one on the bottom, so we're able to cancel those factors. We have m is equal to ju divided by n, and that is the correct answer to our problem. All right, let's look at example B. This is question number 5, part B on your test 3 review for 1033, Math 1033, Intermediate Algebra. We're solving for the letter x. Now, here's what I want you to notice. This term has the letter x in it. This term also has the letter x in it. And if I'm trying to solve for a particular variable, the terms that have that variable in it need to be together on one side of the equation. So the quickest way to accomplish that here, to put all of the x's, let's say on the left, would be to get rid of this minus 2x from this side, and in turn it would then show up over here. And you're going to do that by the inverse operation, which would be to add 2x to both sides. Our equal sign is still in the middle. On the left-hand side of the equation, we have ax plus 2x. And on the right-hand side of the equation, we simply have the letter capital L. Now, the x's are together on the left. The non-x's are together on the right. If I want to solve for x, that means that I only want to see x one time. Well, people, this is a perfect time to use your ability to factor. This is great. If you look at this expression, you'll see that each of these terms has x as one of its factors. So if I use x as the greatest common factor, it can go in front of, and in parens we will put a plus 2. So by factoring, what we were able to do was to make x appear only one time. And of course, when you're solving something for a letter, I only want to see that letter one time. So factoring was a really important thing to do here. Now pay attention to the fact that this is an implied multiplication. So to get x by itself, we're going to divide both sides by the quantity a plus 2. The left-hand side of the equation, this factor cancels out, leaving me with x. And on the right-hand side of the equation, I have L in the numerator, and I have, my paper would stop moving. There we go. I have A plus 2 in the denominator, and I'm finished. Now, one thing I always warn my students, let's just pretend for a minute that instead of this being an A down here, this was a capital L. Okay, now obviously it's not, but let's say it was. If this was a capital L down here, you would have L plus 2 and you would have an L up here. Those L's do not have the right to cancel because in the denominator, this plus, L plus 2, if it were that, would make this one entire term. And that's why sometimes leaving the safety nets, as I call them, around that quantity reminds you that you can't cancel it in parts. Just a good little tip for future problems where you might want to end up being tempted to cancel long or to reduce. Thank you.